For today's quiz, we're going to be talking about a radiometer. A radiometer is like a novelty device that was created a very long time ago. Turns out they're hard to make. I had students trying to build these before, and they took pieces of aluminum and they posted it on a needle, and this has very little friction, and it never worked. And the reason why is there's a balancing act to get one of these radiometers to work. For those of you that don't understand what I'm talking about, a radiometer is something that you can shine a light on. Let me just turn a light on here. And if you shine it on this, what's seemingly a light bulb, there's little veins inside, and those veins will end up rotating faster and faster. And you saw that I used an incandescent light bulb for this. So we have light shining in on the veins. And just so you know, one of the veins is colored black and the other is either white or silvered. And inside this bulb is, there's a little bit of air, but not too much. So it's mainly evacuated. So our question for today is, we already saw that visible light will cause this to rotate around. But what about ultraviolet? So if you would jot down your thoughts and then put your confidence, what would happen to a radiometer if we used ultraviolet light as opposed to visible light? We get a variety of student responses when we ask this question. Some of the more advanced students will say, look, photons that are ultraviolet end up having a greater, or they pack more energy, and therefore they're going to also have more momentum. And these photons are going to cause this to end up rotating faster. Others will say, well, I don't know if UV is going to go through glass, so maybe that wouldn't affect it at all. So those are a few of the typical responses that we get. Okay, I've turned the lights off. It might still seem bright in here because the camera adjusts pretty well, but I'm telling you, it's pretty dark in here. So I have a UV source, and I'm gonna have to turn the ballast on. You'll probably see a little bit of blue. It's not perfectly ultraviolet. You know, there's UVA, B, and C, but we'll probably still see a little bit of purplish color if I turn this on. And now it's on. And I can hold this right up to our veins, and this won't hurt the camera. I'm trying not to look in it with my eyes, but we do not really get any movement whatsoever. I'm going to switch this to the other side, and this is probably closer to UVA, and we see nothing's happening with this. So I'm going to shut this one off. Now I have another more powerful source. Hold on. I have another more powerful source of UV that I can turn on right here if I can find the switch. Like I said, it's dark in here. This one is really bright. So I'm going to move this up a little bit, and I'll turn that. That is blinding. And you can see we get a little bit of movement with that. Actually, it might be because of the jiggling that I did when I moved this. I shouldn't have moved it. So if we're getting any, I can feel some infrared coming off this. So while these are LEDs, they are still giving off, quite a bit of heat. And so I think that might be part of it. If I take it really close, that's really pretty warm. Surprisingly warm for an LED. Now what we can show you is this is really not going to be affected by ultraviolet. It's going to be affected by infrared. I can take this incandescent bulb, and we know there's a filament in there, and I can, for the most part, get it to start having current going through that filament without it really giving off light that we can see with our eyes, that visible light. So I'm going to start turning the variac up a little bit, and you'll see it's starting to glow a faint red. And the veins of this radiometer are starting to move. And I can barely see that illumination there, but again, the camera might pick it up different. But if I turn it up a little bit more and more, we can see that this starts to rotate our veins. I'm not sure if you can see it. Maybe I need to put it this way. But that'll certainly rotate our veins. Now, if I turned it way up, this will go faster and faster and faster. And it goes pretty fast. But when I take it down where I can feel a little bit of the heat coming off here, we certainly have the vanes that are rotating. I'm going to turn the lights back on and give an explanation. A typical way of explaining how a radiometer works is we have the black vanes on one side and the white on the other. And if heat in the form of infrared radiation will start to go onto each of those sides, we know that black tends to get warmer in infrared light as opposed to white. We say that white tends to reflect and black tends to absorb. And so the molecules that are right next to the black will end up, according to kinetic molecular theory, will start bouncing at faster and faster speeds. Where on the white side, they're probably not going to pick up quite as much speed because they don't have as much total heat next to them. And therefore, when these end up hitting on the black side, they end up delivering a bigger hit than on the white side, which would be slower molecules. And so we say infrared heat, and I can generate some of this, and I can put this around the bulb here, and the heat of my hand should get this to rotate. And it does get it to rotate very slowly. So that's our explanation for today, and that's our quiz for today.